Right now, I want to discuss why the area formula for a parallelogram is base times height, which is actually the same, sort of the same, as the area of a rectangle. So as you can see, we have a parallelogram here. The opposite sides are parallel. And we have this height drawn at a 90-degree angle to the base. That's really important. A common mistake with parallelograms is to assume that the height is measured slanted, not at a 90-degree angle to the base, and using that method you would find the incorrect area. So what we can see here is this parallelogram with the height. To see how the area formula is similar to that of a rectangle, we can take this parallelogram without changing any of its area and transform it into a rectangle by taking this little triangle here and simply moving it over to the other side. By doing that, we've created a rectangle, 90-degree angle. And the base remains unchanged. It's 6 still, just like the original parallelogram, right? Original parallelogram had a base of 6. And the height, also unchanged, height of 3. So the area of this parallelogram is 6 times 3, which is the same as this rectangle here. That's one way to kind of see how those formulas are related. The other way that we can see is if you take a parallelogram like this one here, with a base of 6 and a height of 4, and you draw a diagonal. That splits the parallelogram into 2 triangles. 2 congruent triangles, right? And so if we split those triangles apart, we can see that the area of this triangle is 1/2 the base times the height, and this triangle is 1/2 times the base times the height, and those are the same. The base is the same, the height is the same for each of these triangles because they are congruent to one another. Therefore, if we take those 2 areas, 1/2 base times height plus 1/2 base times height, we're going to get 1 base times height, or just base times height. So hopefully we understand a little better how the parallelogram formula comes about.